right, let's continue. 1.2. Solve for x and y simultaneously. All right, now when we do simultaneous equations, we want our equations to be in the form x is equal to or y is equal to. Now this one is already y is equal to, and you can use it as it is, and then substitute into your equation there. Or you can do the following. So it's really a matter of your choice, because there's more than one method that you can do it. It's no problem. But I am going to show you guys this method. Okay, so if I'm going to take this equation, you guys see that y is negative, no? So take the y over, then we can say 3x plus 2 is equal to y. Okay. Please remember, if you guys kept with the y on the left-hand side, and you took the 2 over and you took the 3x over, then it would be negative y equals to negative 3x minus 2. But we don't want the value for negative y, so you would have had to divide by negative 1 straight through to get your y positive anyways. So please just remember that step. Okay, so this is then equation 1. And y is equal to negative x squared plus 2x plus 8 is equation 2. Do you guys see that both equation 1 and 2 are equal to y? That's why I chose to do this method, but like I said, you could do the other one. So I can just say equation 1 is equal to equation 2 because both of them are equal to y. So I'm going to say now 3x plus 2 is equal to negative x squared plus 2x plus 8. All right, do you guys see that this is now a quadratic equation, because I have a square, I have a variable, and I have a constant. Now remember, a quadratic equation, we always want equal to 0. So I'm going to take these values over, then I'm going to have positive x squared plus 3x, take it over, minus 2x gives me plus x, plus 2, take it over, minus 8 gives me negative 6, equal to 0. I always want my quadratic equations equal to 0, so that I can factorize it. 2 brackets equal to 0, x and x. This is really too easy to use the quadratic formula now. The signs are going to differ, so I'm going to have a plus and a minus. No? The biggest one is positive. 3 times by 2 gives me 6, so plus 3 minus 2, positive 3 times negative 2 gives me negative 6, plus 3 minus 2 gives me 1, so that works out. X is equal to negative 3, or x is equal to 2. Now I'm going to substitute my values of x into y, somewhere into equation 1. So I'm going to say y is equal to 3 times by negative 3, which gives me negative 9, plus 2, y is equal to negative 7. Or y is equal to 3 times by 2, which gives us 6, plus 2, y is equal to 8. Please remember that one of them are not going to be not applicable now. So there's no variable under a square root. I don't see any root here with a variable underneath it. So that doesn't mean now that one of them is not applicable, because where's the root? Where's the variable with the root underneath the root? So both are applicable. Both are going to give me an answer. I need 2 answers for x and I need 2 answers for y. Remember guys, this is a square variable and a constant, which means this is a parabola. This is negative, so that means this is a frown, okay? Y is equal to 3x plus 2. That is an increasing straight line. So that's that. What did we calculate just now? We actually calculated the 2 points of intersection. So there are 2 points. Do you guys see that? That's why we have 2 answers. Both of them are applicable. Both of them work out. Okay, now for 1.3. 1.3 says, consider the following equation. Kx squared plus kx plus 2 is equal to 0. 1.3.1, solve for x in terms of k. Okay, so guys, I can't just factorize this 2 brackets equal to 0 because I don't know the value of k. So what I need to do is I need to say kx squared plus kx plus 2 is equal to 0. That means a is equal to k, b is equal to k, and c is equal to 2. Because remember, the value in front of the x squared is a, the value in front of the x is b, and the constant is c. So what I'm going to do now is I have to go to my quadratic formula, because this is the only reason that I can solve it. I can get the value in terms of k. So x is equal to negative k plus or minus the square root of k squared minus 4 times by k times by 2 all over 2 times k. Now I can simplify this because I can say negative 4 times 2, which is going to give me negative 8. So plus or minus the square root of k squared minus 8k over 2k. And there's my answer in terms of k. My answer still needs to have a k in it to be in terms of k. All right, now if we go to 1.3.2, they ask you for which values of k will the equation have non-real roots. All right, now when do we have non-real roots? We now have to go back to grade 11. We have non-real roots when the discriminant is less than 0. What is the discriminant again? The discriminant is the b squared minus 4ac value that we see underneath the square root in our quadratic equation. So in other words, if we go back to our previous answer that we had here, we've already calculated the discriminant. You guys see the discriminant is equal to k squared minus 8k. Do you guys see that? So in other words, when will it have non-real roots? When that value of the discriminant k squared minus 8k is less than 0. Non-real roots. All right, now I see a minus, so I'm going to factorize. Take out a common factor, k. What is left? K minus 8, less than 0. Okay, now remember this k squared is actually representing a parabola once again. So my critical values are at k equal to 0 or k equals to 8. What does less than 0 mean? When do I have values less than 0? I have values less than 0 when they are negative. So if I'm going to look at my parabola now, my critical values are at 0 and 8. And remember, a parabola goes positive, negative, positive. I'm looking for the negative values. Where are the values negative? Here in between 0 and 8. So what will my answer be? It will have non-real roots when k is larger than 0 and smaller than 8.